So, hello, this is Jan again. We are at step 4. We have segmented our trees. What I did in between the last video and this video is I checked cause something went wrong. I removed this tree and it happened some steps before when we prepared the lower 5 meters of the vegetation cloud. And so we extracted this, removed some noise, and then in the Euclidean clustering denoising, I told you to put 1 here. So what this was before these thresholds. So apparently this little tree, the 5 meters, is less than 1% of all the input clouds, and it got removed, and this resulted in some errors. So you need to make these thresholds carefully. You can also leave this maybe to 0 if you prefer, and this to 20. Apply. It will compute a little bit, but the clear sky filter is the only one which takes some time. Yeah, in the end, we should have 10 instead of 9 trees. I know the cloud quite well. So yeah, this time we didn't lose this stuff, but we have ugly we have some stuff remaining which is undesired. So one more time I will go to Euclidean clustering denoising. I put now to 5%. With this you need to play around a bit. Maybe. So I can check what I do, cause normally I never have this problem. It's the first time cause I make this video. It's just... Oh, okay. Yeah, this makes sense. So I have better parameters. I want 400 points, but only this amount. And this works on a lot and lot of plots. The same thresholds. I just forgot, cause I stopped using my own software for a while now. And this is the first time since, yeah, I forgot which thresholds are good. So isolated tree. We have all points hopefully. Yeah. So this looks like a good cloud finally. What you can do now is 3 filters which don't make that much sense. Filters clusters by their point number. So I always kick out some points which have, let's say, less than 1000 points contained. It will do nothing for this cloud. Then filters, I just put all those filter and explain short. So this is how far is the tree cloud from X and Y position. So this is a coordinate origin now. So maximum 20 meters. Because in my applied case, I'm not interested that far. So it will do nothing. All trees are 20 meters from 0, 0, 0, I expect. Yeah. And now maybe I can show you this. Let me check something. Which is the smallest tree? I will kick it out now. Maybe this, just to show you what it does. So center, we don't have the height. Okay. Filters clusters by their bounding box we can do with trial and error. So again, the same group. And I kick out all clouds which are less than 6 meters. This is good to get rid of undergrowth. It still survives. I kick out everything which is less height than 8 meters. I don't have undergrowth in this cloud. It still survives. So, okay. You didn't want it. Okay. "17 meters. Yeah, now we kicked out a lot of clouds. So now we have only 17-meter high trees. Well, anyway, a good parameter for this is 5, or depending on what you want. The smaller, the more problematic the modeling goes. So I set back to 5. Now we have all 10 clouds. Okay. Now we can do some more filters if you want. And so I can do an Euclidean clustering denoising maybe, or a statistical outlier filter on this. What did I do in my script next? So yeah, I do a statistical outlier filter. 4 times the standard deviation is good. Read what the outlier does. I do a second with slight other thresholds. And a third with also other thresholds. 45, 4. So now this is quite a safe filter in my opinion. I told this already in earlier tutorials. So yeah, we got rid of some smaller point stuff. If you want, you don't need to do. I don't recommend the filters that much. I mean, it's up to you. I use them always a bit, but they are not part of my my real field of application right now, not included in my project. So I cut 5 meters or 4 meters of each tree. I want to get rid of this little red stuff. I have a cloud lower part. So, and now I again Euclidean clustering denoising, this time on tree level, not on plot level. That's why it makes sense. I just want to get the largest cluster back, and to be super safe, 20 centimeter, and I leave the rest. It will accept only one cluster, but the largest for each tree. Oh, and I choose the wrong input result. So I took the upper part, not the lower part. This looks a lot better. And now one more time merging. The largest cluster of the lower part with the upper part. And now this is something which we can model, hopefully. So yeah, let's continue. Make a pause for the video and then the QSM video, which is easy.